All right, let's dive into one of the weirdest, most mind-bending ideas in all of science, quantum entanglement. Seriously, this stuff is wild, but we're going to unpack it, and you'll see why it's not just some weird footnote in a physics textbook, it's actually shaping our future. Let's do this. So, you might be asking, just how weird is this? Well, check this out. That quote, spooky action at a distance, that's from Albert Einstein. Yeah, that Einstein. When the guy who figured out relativity calls something spooky, you know we're about to go down a seriously deep rabbit hole. And this right here, this is the core puzzle we're going to crack open today. Just try to wrap your head around this. You've got two tiny particles. They could be on opposite sides of the entire galaxy, and yet they're connected. What happens to one instantly, and I mean instantly, affects the other. How? How is that even possible? It sounds like something out of science fiction, but I promise you it's 100% real. Okay, so before we get to the how, we need to really understand the what. What was the big problem here? Let's get into the puzzle that had some of the smartest people who ever lived, well, completely stumped. So here's what scientists discovered in their labs. They found they could create these, well, buddy particles. They're linked together in a really deep way. They're entangled. And here's the crazy part. You can take this pair, send one particle way over here, and the other one all the way across the universe. But the second you measure something about your particle, like right now, you instantly know exactly what its partner is doing. The link is immediate, no delay. And this is where things get really weird, because this seems to just smash a fundamental rule of the universe to pieces. I'm talking about the cosmic speed limit, the idea that nothing, absolutely nothing, can travel faster than light. That was Einstein's whole thing. So if one particle is telling the other what to do, that message would have to be traveling faster than light. Instantly, in fact. And that was the hang-up for Einstein. He just couldn't get past it. It was, well, spooky. Okay, so if it's not some secret message breaking the speed of light, then what in the world is going on? Well, scientists finally gave this bizarre connection a name, and once you get what it means, the whole puzzle starts to click into place. That name is quantum entanglement, and what it really means is that these particles have their fates locked together from the moment they're created. They're in a shared state. Think of it like this. You can't even talk about one of them without also describing the other, even if they're a billion light years apart. It's like they're still holding hands across the cosmos. But let's strip it down even further, because this is the key. You have to stop picturing them as two different things communicating. That's the trap. Instead, you have to see them as two parts of one single thing, one unified system. So when you poke one part of the system, the whole system feels it instantly. Why? Because it was never really separate in the first place. I know, that still sounds pretty out there. So to bring this back down to earth, let's use a classic analogy that really helps nail this down. We're going to talk about some magic gloves. Okay, picture this. You've got a pair of gloves, one right, one left. Simple enough. Now, you put each glove into its own sealed box. You keep one, and you ship the other one off to a friend who lives on Mars. When your box arrives, you open it up, and ta-da, it's a right-handed glove. Instantly, you know something. You know with absolute 100% certainty that your friend on Mars is holding a box with a left-handed glove. Seems pretty obvious, right? No mystery, no spooky action. Exactly. That's not spooky at all. The glove in your box was always a right-handed glove. The information was hidden, but it was set in stone from the beginning. So how is that any different from our entangled particles? Well, this is where the quantum world decides to get really weird. And here it is, the absolute crucial difference. Your glove was always a righty. It had a definite state from the start. But the quantum particles, their properties, let's use their spin as an example, are completely undefined. They don't have a state until you look. They're in this weird quantum fog, a state of being both spin up and spin down all at once. It's not decided yet. Now get ready, because this is the part that blows your mind. The instant you measure your particle and it snaps into a decision, let's say it becomes spin up, its entangled partner, even if it's across the universe, instantly snaps into being spin down. You see, your measurement didn't just reveal what was already there, like with the glove. Your act of looking forced a choice for both particles at the exact same moment. That is the spooky action at a distance Einstein was talking about. Okay, so the universe has this bizarre built-in feature. It's weird, it's counterintuitive, but so what? Is this just a fun little puzzle for physicists to argue about, or does it actually matter in the real world? Well, let's look at why this is a huge deal. Oh, yeah. It matters. It matters a lot. This spooky connection isn't some quirky little thing found only in a lab. It's actually the bedrock, the foundation, for some of the most game-changing technologies we can imagine. Think about it. By using entanglement, we're on the verge of building quantum computers. These aren't just slightly faster computers. We're talking about machines that can solve problems that would take our current best supercomputers billions of years to crack. Or how about communication? Quantum cryptography uses entanglement to create literally unhackable channels. If anyone tries to listen in, the connection is broken, and you know instantly. And we're even talking about ultra-precise sensors that could do things like detect faint ripples in spacetime or map the human brain in ways we've only dreamed of. So, there you have it. We went from a puzzle that even Einstein called spooky all the way to the foundation of future technology. It really makes you rethink what distance and separation even mean, doesn't it? It leaves you with this incredible, lingering question. If our universe has these built-in connections that seem to ignore distance entirely, what other rules of reality are we totally wrong about? What else is out there just waiting for us to find it?